Welcome to my YouTube channel. Dhanesh here. So in this video, I am going to discuss about two important aspects in convolutional neural network, that is padding and stride. It's padding, stride. So, before getting into these two aspects, padding and stride in convolutional neural networks, see, we have discussed the convolutional algorithm. So, how the algorithm works. See, if we give an image of pixel size, for example, if we have an image of pixel size 6 by 6, and we have a kernel of size or kernel or filter of size 3 by 3. Then after we do the convolution operation, what's the output? Output is of 4 by 4 size. So this is the image. This is the kernel or filter we are using for the convolution process, and the output we are getting, it is of size 4 by 4 by using the formula n minus f plus 1. Here n is the size of the image, that is 6. F stands for the kernel or filter, it is 6 minus 3 plus 1, that is 6 minus 3, it is 3 plus 1, and it is 4. That's why we are getting a output map of 4 by 4 size. So this is what we discussed. See, when you analyze here, the image size here, it is 6 by 6, but the output we are getting is 4 by 4. The two disadvantages in this process, what we are facing, there are two disadvantages mainly I can tell. We are losing a lot of data because we are shrinking the image from 6 by 6 to 4 by 4. The first disadvantage here, it is we are losing data because of the shrinking. The image shrinks and we are losing data. So every time you perform the convolution operation, the image shrinks. That's the first disadvantage. So we are losing data. The second disadvantage, when you do the convolution operation, the corner pixels and the edge pixels are not used less in the convolution operation. See, the corner pixels and edge pixels are used less in the convolution operation. So this is the first two drawbacks. I think the first one you understood well, because the image shrinks. I already told you the 6 by 6, it is converted into 4 by 4. The second one, the corner pixels and the edge pixels are used less, and the output, the accuracy of the output we are getting when the corner pixels and the edge pixels are using less, at that the accuracy of the output map we are getting won't be proper. So why it is, I can explain you how it is used less. Because if you have, for example, you have a map of this is a 6 by 6, 1 2 3 4 5 6, 1 2 3 4 5 6. This is 1 2 3 4 5 6. When you do the convolution operation here, see, here you have done the operation. So you are moving the filter. I am taking the filter as, let us assume that it is 2 by 2. Then when we move it for a stride of 1, see, the next thing I will move like this, right? See, when you take this pixel, or if you take, see, in the first build, when the kernel, when we in the first case, this filter is, sorry, this pixel is covered, and in the second case, I am taking like this is for a stride of 1. At that time also this pixel is covered. But what about the corner pixel? This one, when you take about this corner pixel, it's covered only once. So when you move again this, filter for a stride of 1 downward, again you can see this again for a stride of 1, the 2 by 2 filter is moved. At that time also this pixel, and like this, all these pixel will be covered multiple times when the kernel is moving. But in the case, in the corner pixels, this one, this one, this one, this one, and the edge pixel like this, these areas, it's covered very less when the kernel is moving. All the side edge pixels and the corner pixels are covered less. So the accuracy of the output map produced will be comparatively less when we are using this operation. To avoid these two disadvantages, the first one is, every time you perform the convolution operation, the image shrinks and the data is lost. Second one is, the corner pixels and the edge pixels are used less in the convolution operation. So that's also, the accuracy of the output map will be less. So to, address these two problems, we introduce padding. So what we do is, for example, if you are, if you have, you have a map like this. Sorry, this is your input image. Let us assume that this is a 6 by 6 image. Now I will introduce one more row and column, surrounding this. So this is like, it will come like this. It is surrounded by this, like this. So this 6 by 6 becomes, see, when I can show you, sorry, I will draw properly. See, you have the 6 by 6 image. This is 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. This is a 6 by 6 image. When I introduce a padding like this, so this becomes like this becomes like this. Here also it will come. This is a padding of 1. So when I do a padding, here it is, I can tell padding is 1. So again one more layer I am introducing, the padding becomes 2. So this one you can see here, it will become like this. So this becomes like this. This becomes like this. Here the padding is 1. So the 6 by 6 becomes, now it is 1, 2, 3, 4, 5, 6, 7, 8. The 6 by 6 image becomes 8 by 8 for a padding of 1. This is a padding of 1. Again, if you do one more layer like this, here the padding becomes 2. Here surrounding this, if you put one more row and column, then the padding becomes 2. Here for a padding, if it is 1, the 6 by 6 image becomes 8 by 8. So how do you fill this rows and columns you added newly? See, for example, here you have values like 1 0 1 0.5 1 like this. You have values 0 1 0, some values you can put. So like this you have values. So one way of doing is you can put 0 everywhere here. This is known as 0 padding. You can introduce 0 everywhere here. This is known as 0 padding. We call it as 0 padding. Another thing is, see, in this image, if you have all these cases, if it is 1 1 in this area, if it is 1, you can introduce 1 also here. That is another way of you can put 1 in this area. So the most commonly used method is 0 padding. We will put 0 everywhere here. So we can put 0 everywhere here. So this, when you cover with this row, this column, this row and this column, the padding is 1. Again, when you are introducing one more row and one more column again around this, the padding is 2. At that time, this become a 10 by 10 image, 10 by 10 matrix it becomes. So this is the concept of padding. I told you why we introduce padding. See, normally previously I have told you the equations without padding, the equation was like the output, the size of the output is given by the equation. I told you it is n minus f plus 1. This is the output size will be given by the equation n minus f plus 1. This is the equation. So I explained you. When the padding also coming, when we introduce the padding, so the equation changes to n minus f plus 1 to the equation you can rewrite it as n plus 2p minus f plus 1. One more term will come. This 2p also will come. This is the equation. N plus, previously it was n minus f plus 1. Here it is n plus 2p minus f plus 1. If padding is 1, you will put 2 into 1. Padding 1 means you are introducing, these, or surrounding this everything. You will, this, when you cover like this, in this case, the padding is 1 when you cover like this. One more cover when you do around this image, then the padding is 2. That's what. So the equation modified it as, the equation, the new equation is n plus 2p minus f plus 1. So when you do this, see, for example, this is a 6 by 6 becomes 6 by 6. So n is this is 1 2 3 4 1 2 3 4 5 6. The initial that the initial image, it was 6 by 6. I told you this is the initial image. So here the n it is 6. So I can put n it is 6 and padding it is 1. See, it is padding it is 1 means I can write it as 2 minus, if I am using a filter of size 3 by 3 filter, it is 3, then minus 3 plus 1, then it should be 8 minus 3 plus 1. This will be 8 minus 3 plus 1. That means it would be 8 minus 3 means it is 5 minus 3, that is equal to 6. So I am getting an output of same size as that of the image. So here the image size without padding, I told you it is 6 by 6. It is a 6 by 6 matrix. So here after applying a padding of 1, I am getting an image of same size, that is 6 by 6. So by using the padding, by using this formula. So this is the advantage. So this is the advantage of padding. And one more point you need to understand here is there are two types of padding. One is valid padding, and there are in the convolution we can call it as, one is the valid convolution, valid and same. There are two types. So valid means, as I told you, there is no padding, then we call it as the valid convolution. This is valid convolution. Same convolution means if the image is of same convolution. So convolution is of two types. One is valid convolution and same convolution. Valid convolution means there is no padding. Same convolution means if your image is of size 6 by 6, I need an output map of 6 by 6. So that is the case. So, and in that case, the same size, if you are getting, it is that's what I discussed you with that. At that time you can calculate the equation for padding as well. For example, your equation is n plus 2p minus f plus 1. This is the output. This output, in the case of same convolution, the output must be same. That means this must be equal to n. Then what would be the value of padding? This n and this n is cancelled, and you will get it as 2p is equal to f minus 1. 2p is equal to f minus 1, and p is equal to, from this you can write it as p is equal to f minus 1 by 2. To get the same convolution, you need to use the formula for p as f minus 1 by 2. So this is the same convolution. Valid convolution means there is no padding. Now I am discussing with you about the stride. Stride, the jump. So the jump what we will, the kernel will make during, when it moves through the image. So this thing we already discussed. So next I am going to talk about this stride. What is stride? So when this is our image. Let's assume it is a 6 by 6. 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. This is a 6 by 6 image. The stride, see our filter, let us assume that this is our filter. So first the kernel or filter, we placed it like this. For a stride of 1, I will keep it like, from this the jump will be like this. It would be, I can tell you, the jump will be like this. This is for a stride of 1. Okay. See, for a stride of 2, if I am telling a stride of 2, I will explain it here. First I kept the filter like this. This is our filter. For a stride of 2, it will again goes to 2 pixels, 2 cells, it will jump. This is for a stride of 2. Then again it will for a stride of 2. When it comes downward, again, for example, here I can explain you. This is the first position of your kernel. When it comes downward, again this kernel for a stride of 2, when it comes down, it will come like this. This is the position for a stride of 2. See here, the stride is 1. It is 1. When it moves like this, here the stride is 2. When it from here, when it comes like this, here the stride is 2. So it's the jump from one position to another position. See, if when it comes down also the same thing applies. So this is the stride. And when you do a stride of 2 or 3, so what is the output? See, what is the output matrix? What is the size of that? For that you need to use the formula. This is the formula we have to use at that time when using a stride of 1 or 2 or 3, whatever may be. The formula for output is, it will be equal to n plus 2p, I already told you, minus f divided by s, minus f divided by s plus 1. So this is the output at that time. For example, if you have a matrix, input size, it is 7 by 7. If it is input size, it is 7 by 7, I have to put n as 7. And padding, if I am taking it as 0, I am not using any padding, 0. Then filter, if I am taking it as 3 by 3, filter, it is 3 by 3, then f is 3. And a stride of 2, I am taking a stride of 2, then the output will be 7 minus 3. 7 minus 3 will be it is 4 by 2, 2, then output will be 3 by 3. When the stride is 2, again the image will, the output map will shrink more when we take a stride of 2. So this is the output. See, when you calculate this formula, again one more thing, sometimes you will get decimal values as well. See, normally when you calculate this value, you can get even a decimal values as well. If the filter size, see this, I told you, the filter size is usually odd. See, you need to understand the filter or kernel size, whatever we use will be, that is very important. It should be usually odd. It is 1 by 1 or 3 by 3 or 5 by 5. So when we use strides of different, it can be 2 or it can be 3, it can be 4. At that time the output you are getting can be a decimal value. You can get 3.5 or something, you can get 3.5. At that time you can use floor function. In mathematical functions, like you might be heard of these functions, floor and ceiling functions. Here there are two types of functions in mathematics. One is floor function and another one is ceiling function. So here what we use is the floor function. We use floor functions. For example, the floor of 2.31, any number. I'm just take one example. 2.31 is 2, and again floor of any number like 3.9 is also 3. It will be take the it will ignore the decimal values and take the smallest one. But when you take the ceiling function, ceiling of 2.31 is also 3. It will take the biggest number. Ceiling of 3.9 is also 4, or 2.9 is also 4. So it will take the biggest number. So here we usually use this floor function to avoid the decimal values in the case of the convolution operation. So I covered most of the aspects in this padding and stride. So that's all today. Thanks a lot. Thanks for watching.